Okay, so we are now looking at an assignment review, and this one we'll start with the first question, which is on the descriptive statistics. Okay, so we are looking at question 1, where the first question says the computer company received a rush order for as many home computers as could be shipped during a 6-week period. Then the company records provide the daily shipments. So the data that we've been given here, ungrouped data that we have, this is ungrouped data, where we have the numbers that are just open data here that we have. Then we are asked to group these daily shipment figures into a frequency distribution having a suitable number of classes. Okay, so now getting to this information, what is needed here, first and foremost, is to find the range, which is just the difference between the highest measure and the lowest measure in the data set. So getting down to the range, we simply, first and foremost, look at the highest value. So we check from here, we find the highest measure here. So highest, then minus the lowest in the data set. Okay. So the highest measure in this one is 87. So we have the highest and the lowest. So after getting down to the range, we first and foremost need to find from this one, we need to go just our n. From here, we need to count how many numbers we have been given. So the numbers here, we have 42. From here, 1, 2, 3, 4, 5, 6, 7. And then we have these ones here. So the total number here, n, is 42. So what it needs to be done here is that our n is 42. Then we need to, of course, now look at we use this one, 2 to the power k. It should be less, okay, greater or equal to n. Okay, or 2 to the power k should be actually less or equal to n. So we have to find the number where we raise that number to the power k, we should get 42. So should we say 2 to the power 5? Is it greater or equal to 42? So there's aspect where we say this is 32, which is less or equal to, so this one, 32, we first have to find the value of k that first exceeds the 42. Okay, so we go for this one. So we have to find the value of k that should exceed 42. So this one is less than 42. So meaning we have to go for another number that should first exceed 42. So meaning 2 to the power 6 should be greater or equal to 42. And then our 2 to the power 6 there, 2 to the power 6 is 64. So this number is 62.
That's enough.
Okay, so our 64 is So 64 is greater or equal to 42. So the first value that first exceeds 42 is our K is equal to 6. So this is how we've gotten our K is equal to 6. So in this one, we have to now know that our 6 is our K, because it's the number that first exceeds 42 from this interpretation of our K, 2 to the power K should be greater or equal to n. Now, our n is 42. We have to find the number K in such a way that this K should be the first one that should be make us get this exact number 42, or that first exceeds 42. So it is 2 to the power 6, because this is still 4 greater or equal to 42. So meaning that we are getting our K as 6, because K equal to 5 is giving us the number that is less than 42. So our K is equal to 6. So this is the reason why we are finding the class width. So meaning from here, as we are grouping, so meaning getting us the interval or the width. Our width in this case is actually going to be the range, which is highest measure from this. The highest value in this one was 87. The lowest was 22. And then after this, we are to find our class width. So our width here was the 10 point. The 6 came from K as our value of K. So that is our 6K is equal to 6, which is the number of classes. So this is the number of classes. Okay, so here K is the constant, which is equal to number of classes. So we are going to have our K, our number of classes. Okay, so now from here, we can now say that after finding this, we need now to group the data. So we need to count how many, sorry, class width is class. Okay, so our K is a number of classes. So they are 1, 2, 3, 4, 5, 6. So these are the number of classes that we have. And then we need to now sort out this. We go for the width here, it's 11, approximately 11. So we need to see our lowest value is 22. So start counting from 22 itself. 22 to 32, we have 11 there, because it's 22 is included here. So we have 22 to 32, which is giving us it's 11. We'll start counting 22 inclusive. Okay, so 22 to 32, we have that. Then 33 to 43. Okay, we have that. So we need to count how many numbers we have there in between. And then we have 44 to 54. We have, this is the interval that we are talking about. Okay. Okay, so this is about what we have. The 6 came in because of using this. This is the testing criteria we use. So we have to find the value of K, which is the number, as we use it as the testing criteria, which is 2 to the power K, should be greater or equal to n. So we have to find the number that first exceeds the number here. Our n was 42, the total measures that we have in the data set. So the total measure we have in the data set, there are 42 numbers. So when we raise 2 to a certain number, should give you 42, or the number that first exceeds 42. So should we say 2 to the power 5? 5 is not good enough. 2 to the power 5 would be actually equal to 32. So meaning we have to find the number. So 2, we can raise to the power 6, which will give us 64. So this 64 is a number that first exceeds 42 as we raise 2 to that power. So that's why the 6 came in, because of this 42. So the number that first exceeds 42 is our k, which is equal to 6. All right, so this is about how this one came in. All right, so now after finding that, this is how we got into getting to the highest measure and the lowest measure, and then we had to substitute here. We found the width was approximately 11. So after finding 11, we start counting now, starting from 22. 22 itself included, then getting to 11 numbers. So it ended on 32 because 22 was included. Then 33 to 43 because the 33 was included. 44 to 54, we start counting now physically how many numbers are here between 22 and 32. So 22 and 32, counting them physically. Okay, so just for the first one, 22 is number 1 up to 32. So 22 up to 32. So you have 1 there. Okay. Then the other one up to 32. So meaning there is that one there, which is 2. Okay. Then we have another one, which is a 3. Okay. So there's the other one that we need to go for. So up to 32. Okay. So from looking at these numbers, there are supposed to be 4 of them. Okay. So we have 22 to 32. Okay. So getting down to this, we have 1 in that row. And then there's this other one here. So meaning there are 4 numbers that are there getting down to 22 to 32. So there are 4 of them. So similarly, as we get down to the other one, 33 to 43, so counting them accordingly, counting them from here after grouping using this criteria, we had found 4. So just paying attention to details, we had found 4 there as well. 44 to 54, there were 9. So confirming this, counting them using the data here, we found 9. Then 55 to 65, counting them physically, we found there were 14. Then 66 to 76, we found there were 6. 77 to 87, there were 5. So relative frequency is just the frequency over the sum of frequencies. So we found these are relative frequencies. So this is the first part of the question after grouping the data. So this is just about what was going on here. So counting the numbers physically from here, we had found the class width is 11. So meaning from 22 to 32, 22 was included to 32, there were 11 numbers. Okay, so this is there were 4 of them. There were numbers that were between 22 to 32, but the width, okay, was 11. Number of classes 6. That was the number of classes. So there were 1, 2, 3 up to 6. All right. So this is about how this question was all about. So relative frequency, free frequency over the total frequency. Okay. Excuse me. So this is about what this question was all about on the first part of the question. Then getting down to the other one, part B. Yes, please. There is a question.
Yes, there is. Why did we use the 11?
Okay, the 11.
The 10.
Okay, the 11 came in because here we have to find the range first. The range, looking at the highest measure, which was this, 87, and the lowest measure was 22. Okay, and then the 6 came in because of the testing criteria, like I mentioned here, that when the testing, we use 2 to the power k to be greater or equal to n. Now, our n was 42. So we have to find the value of k. So whatever, so 2 can be raised to what power for us to get 42. So if we say 2 to the power 5, 5 is not enough, because to give us a number that is less than 42. So the first number that exceeds this is still 4, which is greater or equal to 42. So meaning we said our k in this case was 6. So after finding k as 6, which means the number of classes, then we had to now use the width. So width we had to find is equal to highest measure. So we have the highest. Okay, then after this highest, you subtract the lowest, and then you divide by the k. Okay, so this is where this one came in. So it was 87, then minus the aspect of the lowest value was 22, then you divide by 6. So we had find 10.8. So 10.8 is approximately 11. So this is about what was going on. Yes, please. There's another question. Is there another question?
No, I've understood.
Madam Hope? Madam Hope, you've raised your hand. So there's a question. Yes, please. Okay, well, let's proceed. All right, so this is about what this one came. So now finding the frequencies, you have to count physically how many they are. So 22 inclusive to 32, 33 inclusive to 43, the 11 numbers, 44 inclusive to 54, counting them physically from this table. We gave us these frequencies, and the sum of frequencies gave us 42, then getting to the relative frequencies. All right, so getting down to the part B of this question, consider the following marks obtained by 20 students in a quantitative methods class test. Construct a stem and leaf diagram for these marks to assess the class performance. So what is needed here is just for the stem and leaf, we have from 0 to 9, because the highest possible mark was 93. And then the lowest possible mark was actually 8. All right, so now here, the stem and leaf, so the first one, the first number what we have is so from 0 to 9, So we have from 0 to 9. So we have 0 to 9. So they have the 0, 0, 8. That's the first one. So 0, 8 here. We don't have numbers on 12 or 10. So here it's just nothing. We don't have numbers in tens, in 20s from here. It's not 20s, but we have just one from 50s. All right, so this is about why this one was dry. There's nothing here on this one. So this is about what this one was all about. Okay, so yeah, so this is why we are saying now, sorry about that. So this is where we are saying here we have no numbers. We have the first one is from 0, so 0, 0, 8. We don't have numbers in tens from here. So no tens, no 20s, 30s we don't have, 40s we don't have. So we have now the other one is 54. So this is 54. Then we have the other one, which is the so if you have any number, 56 will be there. So 56. Okay, so the other one is 54. The other one is the 56. Okay, so 56 is what we have here. So this one is supposed to be 6, 56. There's no 55 there. Then we have the other one is 61. So 61 is this one. So we have 61, which is here 61. Then we have 62, which is 6 and 2. Then we have 63. So 63, there are two of them, 63, 63. So 63, 63. When we have the other one, 64, which is 64 here. Then we have the other one, which is 72. 72 is here. Then we're getting down to the other one, 73. So we have 73. We are getting down 74. So we have 74 here. Then we have 78. Okay, so 78 here. We have 78 there. So after that, now getting down to 80s, we have 81. Of course, we have two 83s, 83 and 83. So 83 and 83. And then, of course, we have 86. Okay, so we have 86, which is 86 here. Then we have the other one is 87. Okay, so we have 80. So the one was there, 87. So 87 is here. We have 88. 88, we have it. Then 89, we have it. Then also we have the 93. Okay, so 93 is this one. So if we draw from here up to here, we would have to just know that the data set is skewed to where it is concentrated more. So here, so when the points are concentrated to the right, it means that it is skewed to the left. So from here, this data set is skewed to the left. From here, okay. So this is the shape of the shape. We are simply saying that this is skewed to left. So when the data is concentrated more on the right, it means that it's skewed to the left, as can be seen here. So this is skewed to the left. Okay, so if you can draw a point, you will find that the data set is skewed to the points are concentrated more, okay, to the right. So it is skewed to the left. So the data set is skewed to the, according to this one, the stem and leaf plot describing the shape of the data. You are simply saying that this is skewed to the left. Now, testing for outliers, in this case, we have to arrange the data in order. So it's 08, then getting down to 54, 56. Okay, so getting down to this, we have testing for outlier, we have the numbers where we have the position of the median. So the median, okay, so position of testing for outliers, we have the one thing that we need to use here for testing for outlier. We use the lower limit. So for the lower limit, we simply say is equal to Q1 minus 1.5 on interquartile range. Then getting down to the upper limit. So on our upper limit is actually equal to, so this is Q1. Now here, this is Q3 plus 1.5 on interquartile range. This is only how we get to the upper limit. Okay, so now getting down to the lower bound from this information after arranging the data in order. So position of the lower quartile is 5.2, 5.23. So you get the 5th and the 6th position. So it's 1, 2, 3, 4, 5, 5th and the, so this is what we get to get the lower quartile. We get the 5th and the 6th position, which is 62 plus 63 divided by 2, it is 62.5. This is the lower quartile, Q1, after getting the position. Then position of the upper quartile is giving us 3n plus 1 over 4, which is giving us between 15th and 16th position. So we got the 15th and 16th position, which is 83 plus 86 divided by 2. So 15th, this is 83 and 86. These 2. Then divide by 2 for the upper quartile. So meaning that it's 169 divided by 2, it's 84.5. This is on the Q3. So interquartile range is 22, which is 84.5 minus 62.5. So this is on the interquartile range. Then after getting this interquartile range, we have to use the lower bound now, which is Q1 minus 1.5 on Q3 on the interquartile range, that is. So it's 62.5, okay, then minus 1.5 on 22. We are getting 32.5 minus 33, which is 29.5. So from here now, we have to now find the upper bound, which is Q3. Q3 is the upper quartile, which we found at 4.5, and then plus 1.5 on interquartile range, which is giving us 117.5. The interval is given by 29.5 and 117 for the lower bound. This is the lower bound, and this is the upper bound. So all these figures or values that we have here, these ones that we have, should fall within the interval of 29.5 and 117.5. So of course, there's 93 falls within the interval. Only 8 does not fall in this interval. 08 does not fall in this interval. Therefore, we have an outlier. Yes, there is an outlier, which is 8, because it falls outside the range or interval of 29.5 and 117.5. So we have confirmed the outlier in the data set that we have here, because 8 does not fall within the interval of 29.5 and 117.5. So we have an outlier in this data set. Now, getting down to part C of this problem, the following is information on the number of defective components in 1000 boxes. So we get the number of boxes, this is the frequency, and then we take this one as X, or X value. So we have to find the arithmetic mean for the defective production line. So arithmetic mean, what is going on here? Number of okay, so number of defective components is X, and number of boxes is frequency. So we need to multiply 0 by that, we get 0. That one by this one, we are getting the last one. So it will get f of X. So arithmetic mean is just equal to the summation of f of X divided by the sum of f. So meaning on this one, we are getting the 2000, then we divide this one by the sum of f, which is 1000. So our arithmetic mean is giving us 2. So arithmetic mean is 2. So our mu in this case is equal to 2. All right. Getting down to the other question here, the following is a distribution of weekly wages of 600 workers in a factory. So this is a grouped data because it has a range of values. So this is the frequency. Okay, so this is the frequency, and this is the grouped data. Okay, so because it has a range of values. So the weekly earnings and number of workers. So below 875 is 69, 875 to 950. Okay, so between it, so for this one, the following it's of weekly wages of 600 workers in a factory. So this is a grouped data. So we have the weekly earnings and the number of workers. All right, so here below 875 it was 69, 875 to 950 it was 167, 950 to 10,025, 950 to 1025, 207, 1025 to 1100, 65. Then we also have the other one where we are looking at the 1,100 to 1175, 58. So draw the OGIVE for the above data. So there is a term OGIVE, and then so obtain the median value. Okay. So we obtain the median, obtain the limits of the weekly wages, so central 50% of the workers, and then estimate graphically the percentage of workers who earned wages of 950 and 1,250. So under this one, for this one, we have the aspect resolution here. So class, the number of workers, the cumulative frequency, we are simply adding this. So this one plus that, we are getting this. This plus that, we are getting this as we are accumulating the frequency. So this is about what we have. Sum of frequency. So under cumulative, this is sum of frequency. So it's a sum of F. So under this one now, the OGIVE table for the weekly earnings is given by, so upper class boundary and cumulative frequency. So upper class boundary and the cumulative frequency. We use upper class boundary and the cumulative frequency. So we're using these upper values and the cumulative frequency. Okay, so this is about how the OGIVE is drawn. So the upper class boundary and the the cumulative frequency. So this is about how we are getting this O-give. So to draw the O-give, we use the cumulative frequency against the upper class boundaries. Okay. So the upper class boundary for each interval is the highest value in the interval. So the cumulative frequency here against the upper class boundaries. So 875, we have 69. Then we have 950 and the other one. So here the median value is approximately from the O-give, 50% of the workers present the median, which is the Q2. All right, so this is the Q2 from the question says we need to estimate the median value. Okay, so therefore the median value, therefore we have the 50% of 600, therefore from the O-give, 300 components. Okay, so 300 corresponds to the weekly wage of 985. So 985 is the median. So Q2 is equal to 985. Okay, so that is it. The median is 985. So 50% of 600 is 300. So it's 985. And this can also be presented using the graph so that you draw this to scale. So when after this one is drawn to scale, our median is 985. Okay, so we count here the way they're supposed to be. So we are getting down to the upper boundary and the cumulative frequency for the O-give. We have answered the first part of the question to draw the O-give and estimate the median. Roman numeral number 2, obtain the interval now. Okay, the limits of the weekly 50%. So obtain the limits of the weekly wages of central 50% of the workers. So now here we are going to have the lower quartile position is 1/4 of that. So it's 150. So come and get 150 here, getting down to this. So the lower quartile from the graph corresponds to 150. We draw here to be lower quartile is approximately 910. That is the lower quartile. Q1 is 910. Then we get into the upper quartile, which is the 3/4 multiplied by 600, which is 450. So 450 somewhere here, we draw approximately, it's giving us our upper quartile as 10,060. It is 1,060. So our Q3 is equal to 1,060. So the limits will be just within the lower bound, which is Q1 and Q3. Okay, so and our median is 985. Median is 985. So in a nutshell, we are simply saying our Q1 is 910, Q3 is 1060, which is 1060. So this is about, these are the limits that we go for the lower quartile and upper quartile. From there, then there's an aspect where now we estimate graphically percent of workers who earn the wages of 950 and 1,250. How many were they? They estimate graphically the percentage of workers who earned between that and that, 950 and 1,250. Okay, so 950 and 1,250. So here we have the 590. So 590 for 1,950. This one. Okay, so I'm simply saying about approximately giving us from the table here, we can simply locate this one as 590. Okay, so we have a 590 here at this point, 590, and then the other one for 950. Okay, so 950, okay, is approximately 236 from the graph. Okay, so 236 for 950 here to 236, 236. So we can now substitute here and find the number of workers. So meaning 590 minus 236 over this, so it's approximately 59%. So from the graph for the 1250, we can locate and find number of the frequency, number of workers, and for that to 950 can get. So we are simply getting to 59%. This is about question number 1 on this one. Now we can get down to question number 2 of this problem. Of course, question 2 had 2 questions. Okay, 2 questions here. So we need to now carefully understand it. So this one is talking about probabilities now from the descriptive one. So according to the store's historical records, 65% of the digital camera customers are male. So 65% of customers are male. 18% of camera customers purchase the extended warranty. And 10% of camera customers are female and purchased the extended warranty. And then they're saying determine the probability that a male customer will purchase the extended warranty, that's for Max. And then the other one, are female customers more likely to purchase the extended warranty? Just fire your answer. So this is about the question that we are looking at. All right, so probability of male is probability of male is 0.65. Probability of the warranty is 0.18. Probability of female and warranty. Okay, so 10% of customers are female and purchased the warranty, which is this amount, 0.10. Okay, now the gender here for the first table, table 1, can do this in the tabular form. So table 1, we are simply saying this, the gender here is female and male. So no warranty and the warranty, then we can find the total there. So the total for the warranty is 0.18. Okay. Why you are saying 18% of camera customer purchased the extended warranty, which is 0.18 for the warranty. And then the probability of a male is 0.65. All right, so this is what we have here. Okay, so we can be filling in the table as we go. So the question says the complement of a male customer is a female customer. Therefore, probability of female is 1 and probability of male, which is 0.35. So probability of female is 0.35. So female is 0.35 on this one. The complement, so that we get a appropriate value. So it's 0.35. Then we can move on and sort out what is remaining here, because the total should be 0.35. So we can find here no warranty for female by subtracting the 0.5, okay, minus the, so for the female, it will be, what we're simply saying is that the probability of female and warranty 0.10. Probability of female and warranty is 0.10. So female and warrant 0.1. Okay, so female and no warranty, it will be the subtraction. Okay, so female and no warranty is 0.25, such a way that female and warranty is 0.1. The total should give us this. Okay, so from here, we can get female and no warranty is 0.25. Okay, so the probability of male and warranty, we can subtract, which will give us 0.08 because of the 0.08, male and warranty 0.08. So male and warranty 0.08, so that as we add, we can get this 0.18. Then male and no warranty, it will be the 0.65 minus 0.08, which is 0.57. So 0.57. Okay, then addition of 0.57 plus 0.25, 0.82. So 0.82. So from here, we can find the total, which will give us 1.00. This is a summary table that we should have from this question. Now, determine the probability that a male camera customer will purchase the extended warrant. Okay, the male will purchase the extended warranty. So similarly, so here we have the first one. So these probabilities were computed using this. So warrant and male. So given that, so warrant given that it's a male, so probability of warranty given that it's male, probability of warrant given, so probability of warrant and male, so it's a conditional. Okay, so this is on the conditional base. So probability that's warrant and male. So we're simply saying probability of warrant and male or probability of male. So 0.08 over 0.65. Warrant and male. Okay, warrant and male. So it's this, or probability of warranty, which is 0.0. So probability of warranty, we're simply saying 0.6. So probability of male is 0.65. So probability of warrant and male. So probability of warrant and male. Okay, so intersection or probability of male, which is 0.65. So the answer is 0.12307. So there is a 12.3 chance that a male customer will purchase the extended warranty. So this is on the Roman numeral number 1. Then the other one says, the second one, are female customers more likely to purchase the extended warranty? So let us find first the other probability. So the other probability to be warranty given female. So probability of warranty and female, which is 0.1. So probability of warranty and female, 0.1 over probability of female, which is 0.3. So this is 0. So here, a female customer will purchase the extended warranty approximately 28.6% at a time, which is considerably higher than 12.3. So chance a male will purchase the warranty can be seen from the computed values. So here, the female customers are more likely to purchase the extended warranty. So yes, we simply say, yes, female customers are more likely to purchase the extended warranty. So that's the conclusion on this one. So yes, female customers. So you're simply saying, yes, female female customers are more likely to purchase the extended warranty. So here, the question here says, female customers more likely to purchase the extended warranty. Yes. So female customers are more likely to purchase it. So female customers are more likely to purchase the extended warranty. Okay. So this is what this question was all about. So this is what we have gotten by using the conditional probabilities that we have computed here. And what is important is to understand the table: warranty given female, warranty given male. So these are probability percentages. Okay, so the intersection of a probability of male, because this one is intersection of a probability of female. And the way these figures are computed for the female, the total probability for female, since male was 65% male, so meaning the female probability of female, we simply say is what is remaining, so 0.35. Then we are just to go one by one to just sort out this table. So the total for this one should equal to that. This one, it is a total. So we are simply saying male and purchase warranty. Okay, so it's 0.08. Okay, because the total here for the warranty is 0.18. So to get the difference, we had to subtract to get 0.08. And then here we found the 0.65, the total, to get the total 0.5, just finding out this table. All right, so this is what this question came in on the conditional probability. Okay, and the question 2. So it was conditional. So it's just a matter of having time to go through this one. All right, so now we can get to the other question, please. So the other question is looking at as well looking at probability. So it was on probability, question 2. So this is how these figures were computed. These are conditional probabilities. So just a matter of going through them and understand whatever it is that we are looking at. So the most important thing to understand is this table on the conditional probability. You understand just on this table here. From the summary that we have, please take note of this question on the conditional probability. Now, getting down to the other one, which is, this one is on discrete. When you say probability like this one, it's called discrete probability. So under discrete, we have the expected value. So for discrete probability, okay, so under discrete, we have the first aspect is where we need to find the mean. Okay, so the mean is actually given by expected value of x, which is equal to summation of x on probability of x. So this is it, the mean. Okay, so we have this one as the mean. Then we have the variance of x is actually equal to ax square minus ax square. So this is the mean, which would have gotten on the first aspect there. And then the standard deviation of x is actually equal to the square root of variance of x. So this is about what this question is about. So now getting down to this, we have here getting down to the expected value, the standard deviation. It is just x on probability of x. So you are just finding x on probability of x. Okay. So you can incorporate the other column here and then find the figures for what we have on this one. So x on probability of x, then summation of, so 0 multiplied by that, 1 by 0.3 and all that. So this is the mean. You just aggregate the product of each value. Then getting down to the other one, the variance of x. So you go find this first of all. This one is 1.8. Then find this one is a square, x square at a time multiplied by the respective probability. Okay. So this is about how this question came in. So x square on probability of x square on probability of x, 0 on that. The summation of each, we are just squaring x at a time. So you're getting the figure as 4.44, which is not the variance. So the variance therefore is equal to 4.44 minus 1.8 square. This is the mean that we have gotten. And then we sort out that. We are simply getting down to the value of standard deviation 1.095455. So this is it on the standard deviation aspect. So from here now, we have answered the question on this. So we now need to go for the last part of this problem, of this assignment. So the first, this other one is gone. So we just have to use this one concept where we square expected value, just say this multiplied by that, and then we get the mean. The variance of x is x square minus the mean square, which is this variance here. Then we can find our standard deviation, the square root of variance. Then we get to this other question, part C of this problem. Okay, so suppose 10% of scooters will require warrant services within the first month of its sale. A scooter manufacturing company sells 1,000 scooters in a month. So this is a capital N. So calculate the mean and the standard deviation of scooters require warrant service. So this one, we just have to say mean, which is expected value. The formula is equal to NP. So expected value is equal to NP, which is 1,000 by that. So this is the mean. Our standard deviation of X, or this symbol, is equal to the square root of NPQ. So we knew our P is 10, our Q is equal to 1 minus P. So our Q is actually 1 minus the 0.1, and our Q is 0.9. So after finding this, we can find the standard deviation that answers the first part of the question. So calculate the moment of coefficient of skewness and kurtosis of the distribution. So the moment of coefficient of skewness is the measure of asymmetric or distribution calculated by the mean minus mode over standard deviation. So where the mode is the most frequent value, in this case, X is the binomial distribution. The mode is the integer part of the n plus 1. So we are simply saying the mode is 101. Of course, even getting the skewness, we are simply saying our skewness, okay, is actually equal to the other formula to use for the skewness is equal to 3 mean minus median, then over the standard deviation. Okay, so over the standard deviation. So this is on how we get to the mean value, the skewness value. Okay. So from here, we have to just say our mean, okay? Our mean value here is 100. So the mode is actually equal to, okay? We simply say the mean plus 1, n plus 1. N is representing the part of the median, the mean, which is 100. Then plus just a little bit most frequent, plus 1. So we are simply assuming this is 101, the formula for n plus 1. So that's the mode. So skewness is equal to 100 minus 101 using this mean minus mode over standard deviation. So we are assuming that our mode is the most frequent. So our mode in that case, we'll just actually say it is equal to mean plus 1 to mean plus 1. So our mean is 100 plus 1, which is 101. So in this case, we are simply saying the data set is actually negative skewed. So here, since it's negative, the distribution is slightly left skewed. Okay, so this is about what we have on this one. Okay, so this is on the aspect where they are saying calculate the moments of skewness. Moment of skewness, we have gotten this figure as negatively skewed. Okay, so this is about what we have for this given question. All right, then. So this is on the moment of the skewness that we have concerning this part of an assignment. Okay, so we can end the class for now because all the questions are exhausted. So the skewness has been, the mean for this one is just the proportion multiplied by the total measure. The standard deviation is there. And the comment on the skewness, we are simply saying the data set is negatively skewed. All right, so this is what the examiner was actually looking for concerning this assignment paper. So we've looked at the probability for discrete. We've looked at also the conditional probability that came in this kind of question. And then the first part of it was on the descriptive statistics that we looked at on this one, where we looked at the intervals, the cumulative frequency they all give for the data. And then the other aspect where we looked at finding the arithmetic mean from the given information by using this formula. And then, of course, getting down to you finding an outlier using the upper bound and the lower bound for this kind of question. And of course, also finding the stem and leaf for the diagram. And the testing for inner outliers, of course, also grouping, finding the class widths and intervals, and finding the frequencies. So this is how this assignment came in. And just a matter of going through it, you'll be able to understand this kind of assignment paper. So we can end the class for now.
Thank you. Most appreciated.
Okay.